All right, my name is Dom Paris. I'm with Kappa Theta Pi, professional technology fraternity. Just started a couple of years ago and trying to kind of get the name out and get some collaboration. So hopefully this is first of many talks that we can do together, things like that. And we have Otto here, which I'm sure you guys all know. And we're going to be talking about Node. Has anybody used Node.js or familiar with it or know of it? All right, cool. So Node's pretty popular these days, just kind of getting stable, some of the newer releases, and I guess let Otto go through a couple slides on background. Oh, yeah, a little bit about myself. I'm tech chair of KTP, and been working with Node for about a half a year, working on a couple mobile apps and things like that. And we host our website with Node. And Otto here, let's take it away.
Hey guys, how you doing? I'm going to be doing most of the talking today, and he's going to do some examples afterwards, and then we're going to do an example all together, because that's what Node is all about. So I'm on the exec board of Michigan Hackers. Some of you, has anyone come to a talk that I've done before? Okay. This is the first one that's recorded. I've given like 5, so I'm excited to have a recorded tech talk. I'm a senior computer science. This will very likely be my last tech talk because I'm very sick of naming them. Okay, so I'm going to talk about Node. Node is really cool. I've been on the Node train for probably 2 years. I think I've been messing with it. It's actually, I think it's one of the languages out there. It's not a language, it's a framework that has like a mysticism around it for some reason. It's for how simple it is to use and how simple it is to make really powerful applications. It has such for some reason it's got this, it's like for professionals only kind of a thing. So anyway, the guy who created Node works for Joyent. Don't really know what Joyent does. They're like one of those companies that's like a software company. They're just listed as a software company. They've got like all kinds of cool cloud tech. And they also offer their own type of node hosting, which is really cool. If you're ever into it, it's called Node.js. So if you ever have a node project you want to host, Node.js is awesome. Anyway, this guy, if you ever get a chance to watch him speak, he's really weird. He's kind of cool though. Obviously he's cool because he created Node. But yeah. So what is Node? Simply put, Node is a set of libraries which basically have JavaScript V8 behind them, right? So all of the tough thinking was done by Google. Really? Does anyone know what V8 is? So V8 is what's in Chrome. Does anyone use Chrome? No one uses Chrome. Okay. So Chrome is a browser that just about everybody uses for some reason. And the reason that you use it is because the JavaScript runtime on there is really badass. All right? So a bunch of engineers at Chrome optimize the hell out of that thing. And that's the reason that it makes Node really fast. Right? It's solely because of V8. Node is also cool because there's a lot of collection of libraries built around it, which make Node really easy to use. But the point is, V8 is the magic behind Node, which is the same magic behind the browser, right? So it's kind of nice if you're into web applications. The magic on the front end is the same magic as the back end, right? Which is cool if you're a JavaScript developer like me. So Node is essentially sugar plus V8, right? You've got cool things, libraries built on top of the JavaScript runtime. So I wanted to put these in here, but whenever anyone talks about Node, they talk about non-blocking IO. Does anyone know what IO is? Right? Input, output, saving to disk, reading from the database, that kind of thing, right? Things that your app does with the real world. For example, like when you go to a web page, that's input, output for a server, right? The server gets your request, does things, and outputs HTML, right? So it's really important that that happens as fast as possible and that you spend as little time as necessary just waiting, right? So how a typical web server works is it goes to the web server, does a request, and the request literally just waits in the web server until it's done, and then it sends it back. So the old school way of solving this problem was by having threads. So if we said, oh, if we had all these threads that, like, when they had to wait, they would just wait on a thread, so it wasn't so bad. So what Node does is say, okay, screw threads. We're doing a single thread, and we're going to have this evented I/O, where everything is a single threaded event loop. So essentially what that means is, and I'll get into this more detail later, there's only one thread. Everything that happens in Node is happening on this thread. And what that means is when a request comes in, right, on a traditional single-threaded application, you would have to wait for the database to come back before it could respond, right? What this does is it puts a sticky note somewhere in memory that says, come back to this when it's done. And it keeps working. Checks the sticky note, oh, something's done, then it returns, right? Does that make sense? Cool. So these are two very mystified, scary terminology things that are really just simple speak for it doesn't wait around. Ah, fancy, huh? So that's the thing. Node is not fancy, right? Node is simply, well, it is incredibly fancy, but don't be afraid. Because when you write Node code, all of that fanciness is abstracted away from you. Right? You never write anything that deals with the event loop. You never have to think about sleeping or locks or mutexes. Or has anyone taken operating systems? If you take an operating system, you know firsthand how horrible it is to work with locks. Sometimes they make sense, but oftentimes it's kind of the old way of doing things, in my opinion, as a JavaScript engineer. So, Node is the culmination of well-thought-out open-source technology. Right? They took all the badassness that Google poured into V8, which is an open-source project, and built an open-source backend out of it. In my opinion, at least, Node.js is very easy to learn. You get to decide for yourself later. The other thing is, don't be afraid of it. I don't know why some people are like, oh, I could never learn Node.js or PHP or whatever. It's not as fancy as it sounds. Okay. But don't tell your parents that, because they'll think it's really fancy when you're like, oh, I know Node.js. But anyway, so yeah, if you want to install Node, you're welcome to do this now, so that when we give you demos later, you have Node ready to go. This is how you run a Node application. You don't have to compile or anything, you just run it. So Node has this cool thing called package manager. So if any of you have ever worked with like Python or other languages that have packages, essentially what you can do is you can say, I'm going to grab this tidbit of logic that somebody else wrote and plug it into my app. So like a very common one that's used is called Express. That's basically a web server that's ready to go for Node. We'll have a demo on that later. All you have to do to install one of these packages is just npm install. The great thing about these is it's a huge, huge community of Node developers that contribute open source content. So there's like some of the coolest packages that do like silly things, and some are like very important and do some really hardcore stuff. And the coolest thing about that is you can have modules written in other languages that Node can talk to. So if you wanted to write a Lisp module, for instance, you could plug in Node to talk to that Lisp module, right? So Node often does that for things like encryption or image resizing, yada yada.
Node is also great because it's one of the fastest growing ecosystems in web right now, and it's going to continue to grow as more open source developers kind of tack on.
Okay, so this, I'm going to walk you through like your very first Node project. Right, this is kind of the hello world of Node, except it says hello machine hackers. So I'm going to basically break these down for you. So the first thing you do here is you have this require statement. This HTTP is a module. Like I explained, you can get other modules. This one's built into Node. HTTP, does anyone know what HTTP does? Someone said it, HTTP, right? So simply put, HTTP is a module that lets you interact with HTTP. HTTP is how you connect to a web server when you get on Chrome, right? Or Safari, or whatever you use. So what you do is you say HTTP create server, which is going to create a web server for you. You pass in a callback function, and then you say listen on a port. Right? So remember up here we have this callback in there. See that orange? That orange is just the callback, right? And this is what that callback looks like. It's just a function that takes a request and a response, and then it just says response.end with this content. You can do all sorts of fancy stuff, like you can load a response bit by bit, which is kind of cool. Has anyone ever been to a web page that like loads as you really? So this is done asynchronously, right? You load a little bit and it kind of loads as it goes. That's exactly what this does, right? So I'm not doing that, I'm just sending it right away. And then this will actually be the first example that Dom goes through. But that hopefully helps you understand a little bit. Easy, right? Okay. So the important part of Node, like I said a few times, is that it's asynchronous, right? Rather than waiting around, it comes back when something's ready. So has anyone ever cooked food? Okay, so my mother owns a restaurant, so I often think of things in like, I guess, metaphors, right? I'm a metaphor guy. So anyway, in a restaurant, the chef has like 1,000 things to do, right? So imagine and there's a lot of chefs here. Don't think of them as threads, because in Node, really, there's only one chef in the kitchen. But so ignore the fact that there's multiple chefs here. But simply think of the chef here as a Node program, and he wouldn't ever put something in the oven and just sit there and watch it, right? That's essentially how Apache works, except they solve that by throwing more chefs at it. Node solves that by having the chef be intelligent and know when to come back to get his souffle out of the oven, right? One way to do that is a timer, which Node uses to do certain I/O. Otherwise, it'll have some sort of a callback. For example, imagine if your souffle whispered softly, "I'm done." So that's essentially how Node works. And then the non-metaphorical way to explain this here is that we have requests coming into this event loop, functions that get called, whatever you want to think of it as. You can also think of them as web requests. This mystical event loop, which is actually not as mystical as it seems, it's a single while loop, just ticks through and says, do I have anything to do? If so, send callbacks back. Otherwise, you register those callbacks. Remember the callback that I showed you earlier that took a request and a response and just said, hello, Michigan hackers? These are the kind of callbacks it registers, right? It says, okay, if an event comes in, right, I register the callback that says, hello, Michigan hackers, and I don't send it out until something happens and we're ready to go. It just so happens that there's nothing to do, so it does it right away. But if you went out to the file system and loaded a huge image or something, that takes a lot of time, especially if you've taken 42, you realize in machine time how long that takes to go to the go out of the operating system into disk, then to start spinning a little thing in a computer and then to read memory back. It takes a huge amount of time. So the fact that this is asynchronous and it'll just kick it back whenever it's ready is huge, which means the event loop can continue to do other things, like the chef would continue to make, pizza or something while he's waiting for a souffle. Okay, so I'll say it again. JavaScript is asynchronous because of V8, and things like network database, all that can wait. So Node.js is bad at a lot of things. It's really bad at static file serving. So for instance, my website is hosted in Node.js, which is really a terrible idea because my website doesn't change very often, right? Technically, my website goes out to a database and pulls stuff, but it doesn't really make sense in the real world. So if you were going to serve Facebook, you would never want to serve Facebook from a Node application because Node is strictly terrible at copying a lot of things from one place to another, which is exactly how most web servers work. It's really good at things that are asynchronous, like reading from the disk and proxying network calls, all kinds of fancy stuff that you hear people talking about. Okay, so Node.js was built to work with asynchronous things, and the coolest thing about it is the web is inherently asynchronous, right? You send off a request, you have no guarantee at when it comes back, right? You load your web page, sometimes it doesn't load, right? That kind of thing. That's what Node was built for, not the failing part, but the coming back when it feels like it part. Okay, so go forth in Node. Hopefully my talk helped you be at least demystified about Node, and then these examples will help you actually get started on it. Okay. Thanks. All right, we're going to switch hats here.
Hopefully this works. And, all right. Yeah. So I'm going to run the terminal in my window here because I'm running on Linux and I don't know how to. This is the first time I've done a double screen like this. But actually, I'll just write it. But so our first example is a hello world example, and we're actually just requiring the HTTP module and then sending back as a result, hello Michigan hackers. And we can all access this at this IP address once I put it up. And you just have to run node and then file name 1.js. In here it says we're starting a server. And then if you guys go to this IP, 35.2.223.9, and I've got it up over here. Let's write it over. You can see it just sends back hello Michigan hackers, just as we expect.
Pretty exciting.
By the way, all this code is available on GitHub. Right now, I'll post it to the event so you guys can follow along on your computer.
Can you zoom in a little bit on Sublime?
Oh, zoom in? Hopefully. Nope.
There we we go.
There we go. All right. And as you can see, Node code is usually pretty brief and pretty easy to work with. So our second example here is using that Express module, which is a web hosting module. And as Otto explained, you just do npm install to install a Node module. And this isn't installed here yet, so. And then it's going to run a little script and install the module that you need. Because here we're requiring the module Express, and so we need to have that in our file. And when you run that script, it'll install the module that you need in your directory. And then this is a brief example of using Express to do kind of web hosting. So right now we've got an index.html in this file, and then just our app, our web application. And Express allows you to very briefly say, I'm going to take a GET request, and I'm going to route it to this route. And as a result of that, I'm going to send back index.html. And here our index.html is just a basic HTML file, which has just a form and some CSS, about as pretty generic as you can get in terms of HTML. And then, terminal back. This is not easy to do. So then you just got to go node, app, and then it runs. And then, again, here this is at port 3000, and you guys can all probably see it. Here's the form that we have. One thing that this Express application is doing is when I get some form input, I then log to the console the body of that input. So this is logging as a JSON object, exactly what I'm getting. So here, as people are sending in that form input, it's logging just as an object the actual input that I'm expecting from that module. And that's basically Express. It's pretty easy to use. And then here, we have an example of that async coding. Let me kill the server, sorry guys. So here we have an asynchronous call being made to log chicken, and we're also going to log egg. So the question is, which comes first? What do you guys think? What do you think the order of how this is going to print? Anyone?
Who thinks it's going to print chicken, egg?
No?
Did you guys read the slide? So in PHP, what would this print? That'd probably be an error, but if you put a sleep like that, or a timeout in PHP, what do you think would happen? It would print chicken egg, right? That's it's just asynchronous.
Yeah, so here we register the asynchronous callback to chicken, and we're going to log chicken a second after logging egg. But even though in code they're in different places, it's that asynchronous that kind of throws you off, so you don't really get exactly what you're going to expect every time. And another example of asynchronous coding is here, just a general for loop where we say log to the console this I value. And because it's asynchronous, we may or may not have exactly what we expect. Generally, you'd think this might log just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But when you run with asynchronous coding, it actually spits out all 10s. The reason this is happening is because it steps through 10 times and it registers this function call to basically log to the output the value of I after 100 milliseconds. And that after that 100 milliseconds passes, it's already through all 10 steps in the I value. And the I value that it's printing is then just 10. So it just prints I 10 times, which is just 10 at this point. And using normal C++ or something, it would step through one by one, whereas here with asynchronous callbacks, it's a little bit more confusing. And then our last example here is a little chat server we have set up, which is basically a good example of how simple and easy it is to do a lot with Node. Here we are, and actually Otto can explain this a little more.
Yeah.
But basically, we're requiring the TCP module that Node provides, and then we have in here a function on a TCP socket. So when someone opens up a socket on our server, then we're functioning on these two events. And yeah, go ahead, sorry.
So when we call this net.server thing, this says, okay, TCP module, instantiate a server for me. And right away we tell that server to listen on 1024, right? So this happens, and actually you can run this in so
yeah.
Sorry.
Yeah. Okay.
Is it running?
Yeah.
Okay. So if you go to this IP again, you can join in on our chat engine, which will hopefully not crash. This is like 25 lines and has almost zero error checking. So in the real world, you probably would not actually use this. It would be a little bit longer. But either way, what happens is this callback gets called for every socket that is opened with this server. So what happens is we say, okay, a socket. I'm going to put the laptop down.
All right.
I'm going to put the. Okay. Is it working?
Yeah. Actually, if you connect it up through terminal, sorry.
Yes, the IP is 35.2, 22, 3.9. Oh, there's no point. Sorry, I read that really wrong. Throw it at you again. 35.2.223.9. And then if you want to connect, you simply type NC, that IP address, and then 1024. NC is netcat. It'd be cool if y'all got it in here. Oh, it's section from. Connection reset.
But if you connect using this netcat, then you can just chat back and forth. And this is a tool used for TCP. Yeah, see, there we go.
Cool. So see, these are things that people are saying. Cool, huh? So I'm going to explain how this works. Essentially what happens is, it's going to say, okay, socket, push it on our socket queue, right, or our list of all the sockets that will come. And what we're going to say is, when we get data from that socket, we're just going to log it. It's going to say, we received data to string, just takes the data and prints it to the console. And then what we do is we say, for all the sockets that we have that aren't us, right, this socket is going to be equal to us, print it, right? So what it's going to do is it's essentially working like this. You have a connection coming in, right, and it's got this list of all the sockets, and it sends it back out to you, right? And if this comes in, it goes out to it's kind of like a starfish short note. But basically, we wrote a very complicated TCP-based chat engine in 25 lines of code, including comments. So if you guys are, what's that? Any questions about this, by the way? Did I explain that thoroughly enough? So basically, okay, see that's the kind of thing, someone pasted like an image in there somehow. You can get really, remember how I said there were terrible things that you could do with this because we didn't know error checking? There's horrible things you could do with this, right? You can actually, like if this were going through a web browser, you could do what's called cross-site scripting, that kind of thing. Basically, plain nicely, you can say swear words and stuff, yeah, it's great. I'm surprised no one's typed rm-rf yet. Anyway, it's all sandbox, so it's fine. But anyway, the point is, these are events. Is everybody done? So basically, these are events that the socket. Pretty cool. Alright, does anyone have any questions? Alright, we did it. Any quick questions about Node? How to get started? In the real world, Node is actually a lot more complicated because you've got to manage error cases. For example, if someone gives us an image, we would probably throw that out. If someone sent us really malicious content like a binary, it's possible that that binary might accidentally run, that kind of thing. So in the real world, Node handles a lot of these error cases, but in the real world, if you're writing this kind of code, you probably have exceptions that you handle, that kind of thing. But the point is, this kind of thing is very easy to write, and writing the same thing in C++ would literally be thousands of lines of code. But the trick is, behind V8 is actually C++ anyway, so no matter what you do, you can't really get away from C++. So, yeah, any questions about Node? Fine, how do that? We don't want to have a question. Yeah.
Is the GitHub or like?
Yes.
It's on the Facebook.
The GitHub is in the Facebook group. All of the examples are up, as well as the slides. Also, if you guys ever have questions, feel free to reach out to Dom or I about like miscellaneous Node questions or how to get started. I really recommend if you're looking to get into back-end web development or even back-end and front-end web development, JavaScript is a great thing to learn. Right? There's been articles lately about how in the future everything will be JavaScript. So being a JavaScript engineer is super valuable. So I recommend it. Any other questions? Matt?
How does Node tie into databases?
So Node connects to databases the same way anybody else does, over TCP usually. So for example, you can import modules to connect to MySQL, and there's like an interface to connect like you see in any other domain. If you want, on my GitHub, there's some example on how to connect to MongoDB and MongoDB. Yeah.
So how does does it do like an MVC style framework for an actual web page?
So Node itself is not MVC, right? Inherently, it doesn't have any kind of structure. It's essentially a blank canvas when you start. But if you want it, it's very easy to incorporate MVC style approaches. But oftentimes, I wouldn't say that people would associate Node specifically with MVC as much as you would Ruby, which is literally, or Ruby on Rails, which is literally built-in MVC. Because it's basically it's more than a framework. It's more of an opinion than a framework.
It's very freeform. There's a lot of modules to do a lot of different things, and really you just got to find the right module for the job, and that abstracts a lot for you. It's pretty easy to do anything.
Cool. Yep.
Is there any elegant way to do database access?
Yeah, if you don't believe me, I can show you some database code right now. Because yes, database access with traditional databases can be a little bit ugly, but I'll show you. Okay, so I have something called So on my GitHub, I have something called Skeleton, which is kind of my simple Node project. And inside the server, I have a file called database.js. And what this is really hard to read. Okay, can people read that? Cool.
You zoom in a little bit more?
No. See? Okay, I can't. All right. So this is a little bit more complicated than some of the things you've shown. But essentially what you do is you require MongoDB, you say module.exports equals exports. This is the way that modules talk to each other. And you basically say, okay, I'm instantiating a server, give it all kinds of login information, and then you can just say, this API, which is the public API of this actual database, right? So a database.js. So you can say in another module, require database, and then say .connect. But anyway, this function gets called when you start your database, and it just says database.open, and it returns, it basically sets this database object to the global database thing. So it's not particularly important to understand this. This is just the module to connect, but the module to actually use it would be here. Okay, so all you say is you say mongo.connect. See how I said require database.js? And then I can just call that connect function that I just showed you. And basically, if the message doesn't have any errors, I can just say connected, and then I can go about my day. And then to actually interface with the database, I can just say go to mongodb.collection test, and then I can say insert into that collection this document, and then it'll just say the callback contains the documents I just inserted. Make sense? So the weird thing with working with Node is you kind of get into this idea of all these callbacks. This is one callback, two callbacks, three callbacks. That's referred to as callback hell. I've seen 18 callbacks deep. The way you get around that is by modularizing stuff, right? Like I just showed you the database module. Technically, this is inside that callback even. So it's kind of cool. The callbacks are sort of just instructions on what to do next. That's what I think of it as. So, and that's how Node sort of tells the chef, the souffle that whispers softly, "I'm done." It's all done with callbacks, right? By simply calling a function that says, "I'm done. Go do whatever you want next." Does that answer your question?
That would be too elegant.
It's not elegant?
Yeah, like
What do
if
you want?
you do, say, 5 CQ statements in a row, you would have 10 callbacks for variables.
So like I said, the way you get around that is by having modules that do this. In the real world, actually, you can change this code so that this wasn't a callback. You could say collection equals MongoDB collection test. I can't type here. I can rewrite this and it would have less callbacks. So, what did I say? No live coding. No live coding. So that takes out a callback, right? See how I just DNS'd a callback there? No reason to do that.
Another nice thing is that
It's pretty good.
because Node is event-driven, you usually only have 1 or 2 database interactions per event, and that's usually like a different route or a socket IO event, where you only have 1 or 2 callbacks per thing you're trying to do. But then it's broken up in that you're going to do each of those specifically to just the event being triggered.
Also, nobody ever said JavaScript was a pretty language. So there are some languages that are known for being pretty. C++ and JavaScript are not in that category. If you're looking for pretty languages, I suggest trying Ruby, which I've heard is pretty. Yes.
So will anything without a callback block, like for example, line 2 will always finish before line 3, right?
Yes, that's exactly it. So what I did is I made something block, right? So really in Node, it's impossible to truly make a server wait, right? Unless you were doing something really dumb, like you had a loop that was just looping a variable to infinity. So basically, everything in a function block itself will be run mostly. It'll be run mostly sequentially. The only time that won't happen is if you call a function in there that has a callback to the function. Right. So an example of that is if you hit an API, any long-running functions basically get put on the come back later and do this. I'm not really sure how V8 works under the hood with that, but basically there's a this will take a long time, come back later sort of a mentality with callbacks, where so some callbacks get called right away and never even reach like the wait state, right? Does that help answer your question? Basically, some callbacks get executed right away. Sometimes you pass a function and the callback is the first thing that's called, right? Sometimes you have functions, callbacks that are called before, middle, and after during things. It's sort of like a promise, right? So sometimes you'll have, like fail cases where certain callbacks get called depending on what happens. Like you hit a database and on a 200, or you hit an API and on a 200 result, you do something. On 500, you do something. On 404, you do something. That kind of thing. So sometimes callbacks are strictly to do this next. Other times they're come back and do this, sort of. But the cool thing is it doesn't matter to you. You never have to think about it. Did that help?
If people want to learn more about JavaScript in order to learn JavaScript, your talk is still on Mission Hackers,
Yeah.
GitHub, and everything.
There's also, if you're into books, there's a book called JavaScript: The Good Parts, which is like the de facto book you should start reading. There's also another book called JavaScript something else.
The Definitive Guide.
The Definitive Guide, which is like a foot thick. It's like the C++ book that you read in 381, which I cried over many times. The same thing for JavaScript. Basically, if you're looking to just do this level of JavaScript, do that. Also, like learning any language, it's a lot of Stack Overflow. Any last questions? Because we're eating into. Cool. Thank you guys.
Thanks, guys.